Hey guys, so just so you know, first off, I love you. We're starting on conditional probability. So we just finished our first proficiency check for this unit, and now we're moving on to the next thing. So conditional probability is kind of cool. It's a condition that may limit the sample space for an event. So a conditional probability might be like, given that they're in eighth grade. So you're not taking the entire world population, you're only looking at eighth graders. So it's that kind of stuff. All right. So a conditional probability is a condition that may limit the sample space for an event. You can write a conditional probability using the notation of P, and then in parentheses B, then a line A, and then parentheses. It reads the probability of event B given event A. So the probability for conditional formula is if you're given the probability of B given A is the probability of A and, or the intersection of A and B, or when B and A are both happening, divided by the probability of A. So like this is like the part of A that B is part of, divided by all of A. Does that make sense? So for two events, A and B, where the probability of A does not equal 0. See why probability of A can't equal 0? It's because we're dividing by probability of A. Anyway, this next thing is called a two-way table. Now, it can be called a two-way frequency table, but it's a table that keeps track of a whole lot of information. So like this is keeping track of fiction, nonfiction versus whether or not they're in paperback or hardback. This is a very useful way to organize data that can be categorized by two variables. So like one variable, whether or not it's fiction or not. The other variable, whether or not it's hardback or not. Okay? The joint relative frequency table, the joint relative frequencies is the value in each category divided by the total number of values in the two-way table. So like it's the percentages. So like this is the joint relative frequencies. So this is like the percentages. Okay? And then this next one is called the marginal relative frequency. So like this is the percentage out of the whole thing. So this would be like 24 divided by the number of total books, or 82 divided by the total number of books. Okay, that's what that's going to get you. This marginal relative frequencies is the sum of all the joint relative frequencies in each row and column in a two-way table. So like this is the marginal relative frequency because it's that plus that equals that. Does that make sense? Okay. We're going to do a lot of these, so if it doesn't make sense, that's okay. Okay, so the result of a class survey are shown in the table below. So here's our table of a class survey. Do you own a pet? Yes or no? And then are they male or female? So the probability, so it wants to know the probability of owning a pet given that they're female. So what that means for me is that I'm only looking at female. So how many females are in this table? So first off, let's add these. So 8 plus 5 is 13. 6 plus 7 is another 13. This is 14, yes, own pets, and 12, no, don't own pets. There's a total of 26 kids in this class. Do you see that? Okay, so there are a total of 13 females. So how many of those females own a pet? 6. So that's the probability of owning a pet given that you're female. Okay. So now we need to find the probability of owning a pet given that they're male. So if they're male, there's 13 males. And 8 of them own pets. So 8 out of 13 is the probability of picking a person who is male. So given that they're male, 8 of them own pets. Does that make sense? So what's the probability if someone doesn't own a pet? So this now doesn't give us like a given thing. So that means we're only looking at the totals of everybody. So there are a total of 26 kids. And out of the 26 kids, 12 don't own pets. Does that make sense? And 12 out of 26 reduces down to 6 out of 13. Okay. Which is interesting, which is the probability of owning a pet if you're female. Okay. So we're going to use the table to find each probability. So the first thing I'm going to do, this is always the first thing I do when I'm given a two-way table, is I'm going to figure out totals. So 7 plus 4, that's easy. That's 11. Then 62 plus 23, I'm going to pull out my handy-dandy calculator. So I'm going to do 62 plus 23. And I get 85. And then in this column, I get 69. And then in this column, I got 27. Okay, and if I add these two together, it should be the same as adding these two together, which will be the total. Okay, so I'm actually going to find the total, but I'm going to write it in a slightly different color. So that'll be 96 total participants in this job application traits. Okay, so what's the probability of someone having a diploma? So this would be 85 out of the total 96, because we aren't specified here. So we do 85 out of 96, and this is approximately 88.5%. Okay, what if they there was a diploma and experience? Now, please remember that and can be rewritten like this. Okay, so diploma and experience. So yes, they have experience. Yes, they have a diploma. So that's 62. So I'm going to switch colors here so you know what I'm talking about. So this is 62 out of my 96. So because there's no given anything. So I have 62 out of 96. And that's 31 out of 48, which is approximately, we can use our calculator, 64.6%. All right. Okay, now we're given a given. So we're only looking at the kids who have diplomas. So we're only looking at this. So given that they have a diploma, so that's only 85 kids that we're looking at. How many of those kids have experience? So 62 out of 85. So if we do 62 out of 85, we get 72.9%. Okay. And then on this next one, it says, given that they have experience. So this time we're only looking at experience. So that's out of 69, because 69 students had experience. How many of them have no diploma? And that's only 7. So 7 out of 69. So I'd pull out my handy dandy calculator. That's about 10.1%. All right. Any questions so far? Hopefully you're doing okay. Hopefully it's easier than you thought. These are all hopes. Okay, using a table to find conditional probability. So on this table, it shows the distribution of votes for student government president elections. So the first thing I'm going to do on this is I'm going to add up my totals. So if I add that first column, I've already done this separately, so it's on a different window for me. I have 744 freshmen, 1,705. Nope, I'm looking at the wrong thing. Oh, that's why. Okay, so I'm actually going to have to do this by hand. I got this. Okay, we pull out the handy dandy calculator. We're going to shrink it down a little bit. Okay, so I'm going to do 249 plus 285 plus 194. And we get 728 freshmen. And then I do 312 plus 257 plus 212. No, yeah. And I get 781 sophomores. And then I do 205 plus 324 plus 248. I get 777. Yep. Juniors. And then I'm going to do 197 plus 259 plus 318. And I get 774 seniors. Okay, let's see what they voted for now. So we're going to do 249 plus 312 plus 205 plus 197. That's a lot of numbers. So 963 people voted for Keegan. All right, let's do 285 plus 257 plus 324 plus 259. We get a total of 1,125 votes for Wolber. I got distracted. I forgot what my number was. 1125. Okay. Now let's figure out Dow's votes. So we're going to do 194 plus 212 plus 248 plus 318. We get 972 votes. Okay, now we have all those votes. Let's figure out the totals. So I'm just going to do 963 plus 1125 plus 972. And I get 3,060 student body votes. Okay, so what's the probability that a junior voted for Dow? So that means this is the probability of Dow given they're a junior. That's how I'm reading it. So given that they're a junior, so that's 777 votes in total, there's only 248 of those voted for Dow. So I pull out my handy dandy calculator, 248 divided by 777. And I get 31.9%. Okay, what's the probability that someone voted for Wolber? Okay, so there was 1,125 votes in total. Out of the total 3,060 votes. That looks about a third. Let's see. 1125 divided by 30, 60. And that's 36.8%. All right. So the next one says voted for Keegan and was from the sophomore class. Now remember, and means intersection. So this is the probability of Keegan and sophomore. So that means that I'm only looking at Keegan sophomores. So 312 out of the total 360, because I don't 3,060, because I don't have a given. I'm not restricting my categories. So I'm going to do 312 divided by 3060. And I'm given 10.2%. That isn't bad. Okay, we're going to do a whole lot more of these. Don't you worry. Don't you worry your pretty little head. There's more. All right. So this next one says use the table to find, so it says a reporter asked 150 voters how they plan to vote on a new sports stadium and a new performing arts center. Complete the table of the joint and relative frequencies. So right here, here's my frequencies. I can add things up, so I get that 90 people voted yes for the performing arts center. 60 people voted no for the performing arts center. 81 people voted yes for the stadium, and 69 people voted no for the stadium. So what we're going to do is figure out those percentages. So we're going to do 58 divided, we have to figure out totals. So it's 90 plus 60 is 150. So we're going to do 58 divided by 150. And we get 0.39%-ish. So we get 0.39. And then we're going to do 32 divided by 150. And we get 0.21. If we add those together, we get 0.60. Okay. And that's about what 90 out of 150 is, by the way. Do 90 divided by 150. Get 0.6. Okay, let's do 23 divided by 150. And we get 0.15. Then we can figure out this column. We get 0.54. And then I'm going to do 37 divided by 150. And I get 0.25. If I add these together, I get 0.46. If I add these two together, 0.15 plus 0.25, I get 0.40. If I add those together, I get 1, which is what I should get in total. I should get a 1 because that's 100%. So if a voter says no to voting for the sports stadium, so first off, that's the probability, and then we're given no to sports. What is the probability the voter also plans to vote no for the new Performing Arts Center? So no arts. So given no sports. So given no sports. So we're only looking at this column. So what did they say no to arts? So this would be out of 69, 37. So we do 37 divided by 69. And then I'll show it in the other one as well. So we're going to do 37. And we get 0.536. So we get 54%-ish. Okay, so let's look at the other one. And remember, we do have rounding error in this because we did a round. So this is saying they said no to the sports. What's the probability they say no to fine arts? So that's going to be 0.21. Oh, wait, that's yes to fine arts. 0.25 out of 0.46. So if I pull out my handy dandy calculator, I do 0.25 divided by 0.46. And we get approximately 54% as well. Isn't that cool? You can use either one. All right. That's as much as we're doing today. Hopefully that made sense. We're going to finish up the rest tomorrow.